This is test ID 1B, component ID 80. It's the precat, or fuel control oxygen sensor, B1S1. It measures the delta or change in O2 voltage. Now the TID, the component ID 80, indicates a minimum limit. The test ID 1B indicates that it is a right or rear on a transverse mounted sensor when dual O2 sensors are used for fuel control. Now the PCM times the change in oxygen O2 sensor voltage during a period of rapid change in fuel control. Now a special note here. JTEC O2 sensors have 5 volts present when they're cold. The equipment you hook up will change this reading. You may want to review JTEC O2 sensor operation. The sensor must be at operating temperature for this test to be accurate. Now the values aren't converted into measurement units. Use the data as a relative indication of performance. We'll use vehicle data to show typical values. The monitor fails when the value is below the minimum. And as you can see here, we're well above the minimum on this particular test on this vehicle. Now, if we have a problem, we can come here and do some things. We cannot do a change in voltage over time any other way than snap accelerate. We can't force this into a specialized mode. So we're going to use snap accelerate patterns and lab scopes to help direct us to a problem area. Now we're not always going to be able to identify the exact cause, although the time and speed here is usually caused by a bad O2. So next thing we're going to be doing is we're going to look at scope patterns to help us verify this mode 6 data. Here's another pattern we want to look at. This one starts off right here and goes almost straight up till it gets to the top. It's very quick responding. Notice we get right up to the max. Almost that shadow line we have goes almost straight up. That's what we were measuring. This happened to be looking at the fuel control. We also have the after catalyst monitor shown as well. Now here's one we've separated out. This is a perfect response time. Not everything has to be perfect. You'll see other response times, like this one, where the green, in this case the fuel control, is going up at an angle. That's not necessarily a problem. Remember, not every response time has to be perfect. A slower response time is acceptable. Not everything's going to be perfect. Slower than perfect doesn't mean it's bad. Let mode 6 guide you and tell you which ones to look at and measure. So this is an overall look at response time. Remember, let the car run nice and warm, do a quick snap, and then you can stop and look at the response.